Okay, Transcended back here. So in this video, we'll talk about incline plane. So what is incline plane? We need to understand, we need first to know what an incline plane is. So an incline plane is just basically a simple machine consisting of a sloping surface used for raising body what? Or we can say heavy bodies. Okay. And we know everyone has been into this situation. So when we're talking about an incline, basically we're talking about something is moving at a slope. So if this is the slope, maybe it's a road, then this is a slope. Then someone is moving maybe from here, from this point, going all the way there. And this is maybe the slope is like that. So we can call that one as an incline. Okay. Now, we need to know something important under incline. Okay. So first thing we should need to understand under incline is we are going to be calculating the what? The acceleration. Okay. So we need to know how to calculate the acceleration. Also, we need to know how to calculate the forces acting on it, and a lot of things. Okay. So let's start now. Let's start. Okay, now let's say we have got an object. Maybe let's say we have a box there. Okay, and we know that that box, it will have what? Let's say it has about somewhere there, let's just say 10 kgs. Okay, so now let's call this one as theta. We call that one as angle theta. Okay. Now let's start now resolving the forces. Genuinely speaking, we know that this object is either is going to be moving in this direction or in that direction, but not in this direction. We know that, right? Yes. But now, what we need to understand is this. This object, when you just put it there, we know that since it is at a slope, this object has to go in this direction, provided that there is no friction. Okay? So we are going to consider a situation where we have friction and without friction. Now, let's start this problem without friction. Without friction. Another word which we are using here is same as frictionless. Frictionless. There is no friction. So if there is no friction, how can we calculate the acceleration? That is the first question. The friction force and everything. Okay, there we go. We know that when an object is not moving, it's the same as if I have an object here, guys. If I have an object here, if the object is not moving, we have got the weight force and the Fn, which is the normal force. We know that the normal force is the same as the weight force because they're not moving. Okay? That is the same principle which we are supposed to use under inclined plane. So we are considering this one without friction, frictionless. Now, let's resolve the forces. Okay, we know that we are going to have the force. Now, this force, which is going to be starting from here, we are going to have that force, which will be, let me use the white color, that force. And we can call that force as the weight force, which is just basically the mg. Okay, but again, at the same time, we also have the normal force. Okay, we also have the normal force there, which is Fn. But we know that the normal force is supposed to be in a straight line. If I have this guy, they're supposed to be in a straight line. This normal force is supposed to be in a straight line with what? The weight force. Therefore, I can also create another force in this direction, or I can just say, I can put it there. then as we can see, we can also put there, so we can have that. So we have that one, which we are going to talk about it later. But again, there is a force of gravity which we are calling the force of gravity. That force is the one that makes the object to go down here. So we can just label this one. There is another force that tries to bring this object, always tries to bring this object down, and we can call that one as Fg. Okay, we are considering that there is no friction. How can we calculate the acceleration? Well, according to the principle of incline, what we need to understand is that the angle that is formed here, the theta which we are calling it as theta, is the same as the angle which is going to be here. So if we have 30 degrees there, even here we are supposed to have 30 degrees. Why is that the case? If we can check, let's now consider to say we have got 30 degrees. And we know that this one makes what? 90. So 90 plus that one, we are getting 120. 180 minus that one. The answer which we are getting here, again, you are going to consider to say, if you calculate the angle there, from there, because we know that from here to there, it's the same. Okay? So as we can see, this one we are going to get what? 60 as well. Because 90 plus 30 is 120. So for us to make it 180 is supposed to be plus 60. This one is 60. So 60, 80 minus, or 90 minus 60, then we are getting 30 as well. So it's the same, right? So according to the principle of incline, that is the same as the angle which is supposed to be there. Okay. Now, let's say the theta which we have, we are going to consider that the theta is 30 degrees. Now, calculate the acceleration. How do we do that? We can resolve this what we have here, the mg which is going down here. Or let me show it. Let me use this one. What we have here. What we have here. This one. The one which we have there. That is the same as if I can create the what? A small triangle. If I say we have this, then we have that. Okay? So if that is the case, we know what's going to happen. But although necessary, it's not like that. This one is supposed to be like, or let's say, even from here we can just do it. We know that this is theta, which we have there. So this is opposite over hypotenuse. We are going to consider this one as hypotenuse. So we have this. We have that one, and that one. Yes. But no, this one is supposed to be hypotenuse, yes. So this one we are considering as the mg. Then this is the theta, which we have. So this is the opposite. So what is opposite over hypotenuse? That is sine, right? That is sine. Therefore, that is sine, because here is opposite. This is our opposite. Our opposite of this angle is this one, over hypotenuse. So it's sine. So this one is going to be mg sine theta. This one is going to be this guy. It's the same as that guy. So it's going to be the adjacent over hypotenuse, that is the cos. This one is going to be mg cos theta. Okay. Now, knowing that, how can we derive an equation? Let's now start. Okay. So there we go. So according to Newton's second law, F net is equal to, what is the force that makes that object to go down? That is, we only have the Fg. But as we can see, Fg is going in the same direction as mg sine theta. They are all going in this direction. Therefore, we can set them equal to each other. Therefore, we need to know that Fg will always be mg sine theta. Again, we know that the normal force, we are getting it with perpendicular to what? The line which we are going to have. So as we can see, the line there is mg cos theta. Therefore, the Fn is supposed to be mg cos theta. So even the Fn is supposed to be mg cos theta. These two formulas, we need to get them. So we know that Fg, the force that makes the object to go down, that is mg sin theta, and the normal force is mg cos theta. Now we can continue now. Okay, now there we go. So we are going to have this, according to Newton's second law, this is ma is equal to, what is Fg? Fg is mg sin theta. Okay, so now if I want to get the acceleration, I will divide by m. I will divide by m. My a is going to be, I can cancel m, and I'll have g sin theta. So my acceleration is equal to, my g is 9.8 sorry, meters per second squared, sin what? Sin 30 degrees. What is the answer? So we are getting the answer as 9.8 cos what? Cos 30. Or sin 30, sorry. 9.8 sin 30. I'm getting 4.9. And there is our acceleration. So this is our acceleration. Okay? That is how we can calculate the acceleration. But sometimes they can give us different questions. Okay? Now, we are using this formula when we have no friction. What if we have got a situation where we have friction? How can we calculate? Okay. Now, let's say here, the same thing which we have, let's consider it to say we have got the friction force now. So the friction force, we know that it's always opposes what? Motion. So we're going to have the friction there, which is going to be Fk, meaning kinetic friction, because the object is moving. So same F net is going to be equal to, what are the forces? The Fg, because it's moving there, and again minus the friction force. Okay, so according to Newton's second law, this is going to be ma. Fg is what? Is mg sin theta minus F is mu times the normal force. If you have not checked the video on how to calculate the friction force, you can just check it out. We know that the friction force is given by mu times what? The normal force. Okay, so even here is supposed to be mu times the normal force. But what is the normal force? So it's going to be mg. We have that one minus, we have normal force is mg cos theta. If I want to divide everywhere by m, and we have acceleration is equal to, if I want, I can isolate m and g because they are the same. So I can say mg, then open brackets, sin theta minus mu cos theta cross divided by m. M is the same, we can cancel them out. So therefore our acceleration is going to be g sin theta minus mu cos theta. So let's plug in the values. So 9.8 sin 30 minus, so let's say our mu value is 0.5. Now we have 0.5 cos 30. Okay, so our acceleration is going to be, we have sin 30 minus 0.5 cos 30. This answer times 9.8. Okay, I'm getting my acceleration as I'm getting my acceleration as 6.84 times 10 to the power negative 3 meters per second squared, meaning the object was moving at a very, very, very slow rate. Okay, so that is how we can calculate the what? The acceleration when we have friction force. Okay, but now, what else are we supposed to know? We can calculate a lot of things. Now, let's change the situation. Let's say we have an incline, then we are pushing the force up. What happened? So what happens there? Let's check. Let's see what's going to happen. What we need to understand is that Fg will always exist. No matter what, Fg has to exist. Okay? Fg has to be there. So what we are going to have is, let's say maybe we have a situation where we have this, then we have theta, then we are applying the object, maybe that is the case, then we apply now in this direction. Now we need to be very much careful. Sometimes they can apply at an angle like this, sometimes they can just apply. So now let's start with the applying it in a straight line. Let's say you have got the force which is applied there, which is maybe, let's consider it as what? 200 newtons. Okay, and let's say the mass there is 10 kgs. So what you need to understand is that the Fg always exists, because when the object is moving in this direction, you discover to say the Fg will always trying to pull this object down here. So the Fg will always exist, but in this case Fg is going to act as the friction force. It's not necessarily the friction force, but it's going to act as friction force because it's going to be opposing motion. But in a case where we have got friction force in this case, or in a case where it is being pulled in this direction, okay, then you are going to have Fg at the same time you're going to have what? The friction force. But now let's start with the situation where we don't have what? Friction force. How can we drive the equation to calculate the acceleration? Okay, so we start. The F net is going to be equal to the applied force, which you can say the applied force minus the Fg. We are saying without friction. Now it is applied, you are applying a force going in this direction. Okay, so we are applying it in this direction, right? So I now want to see how we can calculate the what? The acceleration. So this one is going to be ma is equal to the applied force minus that one. Minus the what? The Fg. Sorry. This one is supposed to be Fg. So what is the applied force? So we can divide m. And the acceleration is going to be, what is applied force is 200. But what is Fg? Fg is always mg sine theta over the mass. Let's now plug in the values. 200, the mass is 10 times 9.8 sine, let's say the theta is what? Still 30. Let's say 30 degrees. Okay, over, divided by what? 10. Our acceleration is, so it's going to be 200 minus, open brackets, 10 times 9.8 is 98. 98 sine what? 98 sine 30. I close brackets. I'm getting, divided by 10, put it in normal, I'm getting 15. That is too much anyway. 15.1 meters per second squared. That is the acceleration which I'm getting. Now, in a case where we have got friction, what happens? Okay, in a case where we have got friction. Now, in a case where we have got friction, we know that friction always opposes motion. So what we are going to have there is this. You are going to have at the same time the friction there. Okay, how can we drive an equation? So it's going to be the F net is equal to the applied force, which is the 200 minus the Fg minus again the friction force. So it's going to be ma is equal to the applied force is 200 minus, this one is always mg sine theta on an incline, minus this one is going to be mu times the normal force. But what is normal force? Again, what we need to remember is that on an incline, mg, or normal force is always mg cos theta. Then we divide by m. So our acceleration is, plug in the values and find the acceleration. That is acceleration which we can use to calculate. Nothing is difficult here. Now let's check another situation. Okay, now a situation where they can ask us to calculate the mu value. Okay, a situation where they can ask us to calculate the mu value. How do we derive the equation? So let's just write it there. We see how we can do it. Let's just put it there. We see how we can do it. Okay, now let's say we have an object, okay, and let's say it's 20 kgs, and let's apply the force. Let's apply the force at an angle. Let's apply the force at an angle. What happens? We apply a force in that direction. Now, sometimes you need to be very much careful. They will not tell you, let's say we apply a force of 450 newtons. And let's say the angle which we have there is 45 newtons. Or 45 degrees. Now, the first question is, they can ask us to calculate the what? Maybe let's say they are saying this guy is going up, right? And there's friction here which is opposing motion, which you can call Fk. And let's say the value of mu is no, because we are trying to calculate the value of mu, sorry. Let's say the acceleration is 0.7 meters per second squared. Okay, how can you calculate, how can you find the coefficient of kinetic friction in this case? Now what we need to understand, guys, is this, or let's just move this one down there. Let's say the acceleration is there. The acceleration is 0.7 meters per second squared. How can we find the kinetic friction? You need just to check the force, the way the force has been applied. They will not tell you that the force has been applied at an angle, but you need to check yourself. Okay, so now if we can check, let's now check the forces acting there. We know that we always have this force. At the same time, we have that force. And we said, we said this is just basically mg sine theta, and this one we said is mg cos theta. At the same time, we know that we are going to have the normal force there, which we can say the Fn. But again, what we need to understand is that we have got the friction force. Friction force, in case you don't know, friction force is always, so the kinetic friction is mu times the normal force, and the normal force is always, anyway, we'll not talk about that because we have done that already. I can just leave it there. Now let's drive an equation which can help us to calculate the what? The kinetic friction. If we can check, guys, generally speaking, this object is does not only have forces in y direction, no. Because this force, as we can see, the 450 newtons, it has been applied at an angle. But we know that according to the principle of incline, we know that this one will also have 45 degrees. But if we can check, this is also at an angle. So we can say that, and again, there is also another force here, which is going in that direction. Meaning, what we have there is the same as we have a block, they apply there, and we have this. Have you seen? So we have the force, this is the same as Fx, and this is the same as Fy. Vectors. Okay. So, it's the same thing if I want to calculate the Fx. Now, according to the principle, now here, what we need to understand is that the angle which is there is the same as the angle, meaning here is also 45 degrees. Meaning, what if I want to calculate the Tx? For me to calculate the Tx, what I need to know is this. I need just to know that here I've got theta. So the opposite over hypotenuse, that is sine, right? So if I want to find Ty, I'm going to say Fy, sorry. Fy is going to be F sine theta. If I want to calculate the Tx, is going to be, or Fx is going to be F cos theta. Meaning, these are the things which I'm supposed to replace there. Here, meaning here I've got it. I'm going to have F cos theta. At the same time, there in y direction, I'm going to have F sin theta. Okay. Now, we have resolved the forces which are acting there. Okay. We have resolved the forces that are acting there. What else are we supposed to know? What else are we supposed to know? Okay. Now, there we go. Let's check. What we need to start, let's start with the forces in y direction. We can start with the forces in y direction or in x direction. It's the same, right? Same thing. Or let's start with y direction. Okay. So what are the forces which are acting in y direction? So I can just rub this, I can just remove this. And let's say consider the forces acting in y direction. So the forces that are acting in y direction, we can see we have got the normal force. This normal force is in y direction. Okay. We also do have mg sin theta or cos theta, sorry. This is also going down. It is also in y direction. Apart from that, we also have the force that is there. That force. This force is going down, but if we can check there. Okay. That is also what? It's going in y direction, but it's going down, it's going to carry negative. Meaning, we have three forces. We have one. We have the force of what? One, we have the force of, we have the mg sin cos theta, which is going down. The normal force, which is going up. Again, the what? The F sin theta. For the applied force, so we can start now. We start with the positive one. So the positive one is the normal force, because it's going up, minus the weight force. So the weight force is going where? Maybe you are being confused there. Let's do this. Let's isolate that guy. This guy is the same as if I have this, if we have that. Okay, then we have an object, then we apply at an angle. So we have got it. This is F sin theta, F cos theta. Now we know that we're going to have the normal force, which is Fn, at the same time the weight force, which is mg cos theta. Or we can just say the weight force, right? But since it's the same as mg sin theta. Yes. So let's now consider the forces in y direction. So we know that F, or we can say the summation of forces this object is not moving there, therefore it's only moving in x direction. So here the summation we are supposed to get what? 0. So we are going to have, we have got the normal force minus the F sine theta, again minus the mg cos theta. So after that we can press this one the 0. We have Fn, we have Fn minus F sine theta minus again mg cos theta. After that we can shift everything here, these guys, to the other side, these fg what, so we are going to have the Fn is equal to F sine theta plus mg cos theta. Okay, so at the same time we can calculate F net. So we have Fn is equal to, what is F? F is 450 sine 45 degrees plus, again m is what? What is m? Our m is 20 times 9.8 cos 45 degrees. So we can resolve that one and we say 450 sine 45 plus 20, or we can put them in brackets, 20 times 9.8 cos what? Cos 45. Okay, so here I'm getting 446 point, you can just say 0.8 newtons. Let's come again. So we are saying 450 sine 45. I may not be accurate, but if you have the calculator, kindly do that. So I'm getting, if I do 450 minus, if I do 450 sine 45, I'm getting 318.199. So we can just say 318.1 or 0.2. Okay, now if we find that one, let's put it there, minus, or maybe let's do this, let's put it there. So I'm getting 318.2 plus, what is 20 times 9.8? 196. So what is 196 cos what? Cos 45. I'm getting 138. 138.6. So that 1.8.6 plus 31, 318.2. Okay, I'm getting the same one. So I'm getting Fn as what? As 5, not 5, but 4. I'm getting 456.8 newtons. So this is our Fn. We are not done. We are calculating what? So that is our Fn. Now we are done with the forces in x direction. Oh, y direction, sorry. Now let's go to x direction. What do we have in x direction? What do we have in x direction? Okay. So we can see that in x direction, we can just lap this part, then we put it there, because I'm running out of space. We can move this part, and let's say we have find our Fn as 456.8 newtons. We can leave it there. Let's now come to forces in y direction. So the forces, or in x direction, sorry, in x direction. In x direction we have got acceleration, therefore it is moving, meaning the F net is not 0. So what are the forces acting there? We have the forces which is the same force which is going in that direction, this force, which is going in that direction. Although this arrow is not supposed, this arrow is the one which is coming here, that other one is supposed to be there. Okay, but what we need to understand is this. I said if you have got the friction force is always opposes motion. We say this is the same as this scenario where we have this, so we have that object there. So we have got the force now in this direction, that is F cos theta. Again, the friction force is opposing. We have got the friction force in this direction. At the same time, I said even Fg is still acting there. Fg is always there, so Fg will also act as the friction force. So the forces that opposes motion, we have got two: the friction force and the force of gravity. Therefore, both Fg and the Fk, they are supposed to carry negative. Then we are going to have this. This is what we are going to have. We are going to have the forces in the x direction. We have what? We have the applied force, which is just basically F cos what? F cos theta minus the Fg, we have said that, minus again the Fk. So according to Newton's second law, this is the Ma is equal to F cos theta minus Fg is always mg sin theta. At the same time, Fk is always mu times the normal force. Okay, so let's not tamper with it to say normal force is what, because we have calculated the normal force already, we know it already. So we want to calculate the what? The mu. Okay, we know the mass, we know the acceleration, right? What should we do? What should we do? Okay, we are supposed to shift the whole of this guy. It has to go to the other side. So if this guy goes to the other side, what are we going to have? We are going to have Ma minus F cos theta plus mg sin theta is equal to negative mu times the normal force. I can divide everywhere by negative, right? Divide everywhere by negative, divide everywhere by negative. Therefore, I'm going to have my mu times Fm is equal to, I'm going to get, this one is going to have negative now, the Ma. This one is going to have positive. So it's the same as if I start with F cos theta minus Ma, then again minus mg sin theta. Because this negative is going to affect there, it's going to affect even here. Okay? Meaning, they are going, all the guys there on top, they're going to have negative, except what? The one which is having negative is going to be positive now. So now I can divide by Fn. I can divide everywhere by what? Fn. Therefore, my mu is going to be the F cos theta minus Ma minus mg sin theta. Divide everything by what? Divide everything by the normal force. Now let's plug in the values. Okay, so if we can just create a space on top there, here, so we plug in the values now. So if we have to plug in the values, we can see that F is 450 cos 45 degrees minus our M is 20 times our A is 0.7 minus our M is what? 20 times 9.8 sin what? Sin 45. Then everything divided by what? Divided by the Fn. But what is our Fn? we know that our Fn is what? Is 456. And before you even come up with the answer, you know that the mu is always less than 1. If you submit your mu greater than 1 or 1 going up, meaning that is not the answer. Mu is always less than or equal to 1. Okay, so here we have the Fn as 456.8 newtons. So there we go. We have mu, or let me put it there. Let's see. So we have 450 cos 45. The answer which I found minus, open brackets, 20 times 0.5 or 0.7. The answer which you find minus again, 20, open brackets, 20 times 9.8 sine 45. So there we are. I'm getting 165.61 newtons. Everything divided by what? 456.8 newtons. Therefore, our mu value is this answer divided by 456.8, and we are getting 0.363. So this is the coefficient of kinetic. So if you want, you can present your answer to say mu k is equal to 0.365, meaning this is the answer. Okay, thank you for watching this video. Have a blessed day.